Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 1, Lesson 2 on discontinuities. So, what are discontinuities? They are exceptions in a domain. So we already looked in the last video, remember we said if there's a fraction or radical, then there is an exception. But what do those exceptions mean? What are they? So there can be, that's messed up. That says there can be two types. There can be three types. Wholes, vertical asymptotes, and jump discontinuities. There may be other variations, but that's what we're looking at. So, what are the differences between those things? So, wholes, if you factor a rational function, remember rational functions are the ones that are like fractions. And if two factors cancel out, then there is a whole. And you can find the coordinates of the whole, the x value, set the canceled out factor equal to 0 and solve, and then for the y value, plug in the x value to the simplified function. Obviously, this might not make sense until you see me solve it out, so just hang on a second. Vertical asymptote. If there is a factor left in the denominator that doesn't cancel out, it has a vertical asymptote. You can find what the vertical asymptote is by setting the factor equal to 0 and state it as x equals whatever it is. Jump discontinuity on a piecewise function. So remember, the piecewise function is where it will be something like f of x, and then it has what? This part, this part, this part, and then it will have something like, oh, there's that, then there's that, whatever. You learn that in Algebra 2. So we'll have a little bit of review on that. But if there's two x values with different y values, then there is a jump discontinuity, like in this case. So let's look at the examples here. We have 6 today. Find out if there's any discontinuities for the following. So what we're going to first want to do is factor. This happens to be rational, so we could have a whole or a vertical asymptote. So let's factor this. On the numerator, we can factor this, still in the race, by doing the bottom up factoring method, which I'm not going to review much, but that would give us x squared minus 5x plus 4. When we factor that, product sum, we would have 1 and 4. They could both be negative. Then divide by 2 that we multiplied with at the beginning, and that would give you 2x minus 1 and then x minus 2. I had a review on factoring for the Unit 0 video, so please see that if you don't know how I just did that. So, now, from the rules that we know, since there's the same factor here and here, they cancel out. And I said if a factor cancels out, then there is a whole. And the wholes are stated in coordinates, so something, something. To find the x value, you set the canceled out factor, which was x minus 2, equal to 0, x equals 2. So that's x value. To find the y value, you plug in what you found for the x, and 2x, put that into the x for the simplified function. We're not putting it into that. That would give us the wrong answer. So the simplified function, since the x minus 2 is canceled out, that would leave us only with 2x minus 1. So we plug in 2 for x, since that's what we found. 2 times x minus 1, 4 minus 1 is 3. So that we have a whole at 2, 3. So that means that would be an exception in our domain and range. Alright, now we have another function. Let's factor this again. So this time, we'll do the same thing. Same kind of factoring. Okay. That would give us 1 times 4 again, but different signs this time. If it needs to be positive 3, that needs to be positive. So then we divide by 2, since we multiply with that by that beginning. 2x minus 1, x plus 2, divided by x minus 2. Nothing can cancel out this time. But since we have a factor in the denominator, we have a vertical asymptote. To find it, set the factor equal to 0, and then we get x equals 2. So we have a vertical asymptote at x equals 2. So we didn't have a vertical asymptote in number 1 because the factor canceled out and there was nothing left in the denominator. So now, what about this one? H of x equals 5x plus 1/2. Well, we don't have a rational function this time, so there are no discontinuities in this one. There are not any discontinuities in this one. Well, that's not necessarily why, just because it's not a rational function, but there is nothing in the denominator that could be a whole or a vertical asymptote, and it's not a piecewise function, so we know that no jump discontinuity. So then, this one here, v of a, let's factor. I don't really like it when there's something other than x, but then again, I made this problem, so, why did I do that? Okay, above, that would give us, let me think, 1 and 12, no. 2 and 6, yes. Need to have a positive 2. So this time, two factors cancel out. That would be the a plus 2's, and that would leave us with a minus 6 divided by a minus 2. So since something canceled out, we have a whole at something, something. Set a plus 2 equal to 0, a equals negative 2. Put that there. Plug in this for a into the simplified function. So it gives us negative 2 minus 6, negative 2 minus 2, negative 8 divided by negative 4 just gives us 2. So we have a whole there. I'm going to erase this for now. But since we simplified and we still have a factor in the denominator, we also have a vertical asymptote. Set that equal to 0 to figure it out. So we have vertical asymptote at a equals 2. So those were our discontinuities. We had both on that one. Okay, number 5. This time we have a piecewise function. And when you have one like this, we might have a jump discontinuity. So we need to see. To figure this out, we're going to need to graph this. You might have graph paper, but you could also just graph this by hand. So there's going to be two parts. We're going to need to figure out how to graph both parts. The first part, we know it's going to be linear. And it's going to be for when x is less than 0. So we know it's going to be somewhat in this direction. How do we figure out the starting point? To figure out the starting point, did I say it up here? No. Okay, so when we figure out the starting point, let me try to figure out how to put this in words, kind of. You have to, I'm gonna look right here, see if I put it in here. What we do is whatever is right here, whatever is right here is our x value. So our starting point is going to be x something. To figure out the y value, plug in your x value to this part. So 0 minus 1 is negative 1. So that's our starting point. And you don't get confused and think, oh, x minus 1, that would mean right here, and then, that actually may be true that that's a point on this, but you need to keep that in mind. So then here we have 0, plug this into here, 0 squared is 0. So those are our two starting points. So 0, 1, negative 1, that's right here. 0, 0, here. And the first one is Oh, that's actually reverse of what it should be. This one's closed because it's greater or less than or equal to, and this one's open because it's only greater than, not equal to. So we already said that this would need to point in the left direction because it's less than or equal to 0. And if you think about it, if this was not a piecewise function, that is what it would look like if it was full. Now, for x squared, since we know that x squared, if we graphed it, that's what it would look like. Not exactly to scale, but that's what it would look like. But since x has to be greater than 0, it would look like this only that part, because it has to be only greater than 0. So now we have two x values that are at different y's, and because of that, we have a jump discontinuity. So jump at where x equals 0. So that is how you find a jump discontinuity. How you know if it has jump discontinuity if there's two values in the same place like that. If this happened to be way over here, then we wouldn't have a jump discontinuity. Oh. There we go. So now, number 6, let's look at this. This time we have another piecewise function that we'll need to graph. Now that I showed you how to do it, I'll go a little bit faster with this one. So 0, 1 would be the point. Or sorry, negative 1 would be the point. For this one, 0, negative 1 would also be the point. So, and 1 is open and 1 is closed. So 1 is open, 1 is closed. It's kind of hard to draw that. This one's going to be in this direction. So that one's actually the same as in the last one. And this one is also a quadratic that's the same as the last one, except it got moved down 1 because of this minus 1, if you remember how to graph quadratics. So, let's think. Is there a jump discontinuity this time? No. And so there's no discontinuities. And that's because since one of these, there could be a hole here if both of these didn't have a equal to, because then that means that value would be excluded, x equals 0. But that's not the case, because one of these is equal to 0, so no value is missing at all. In fact, if you wanted to graph this normally looking, if you want to call it that, it would just look like this. And there's not one value that the x doesn't go through. If you were to like trace down this, there's not one value that gets skipped. So there's no discontinuities for that. So with that, that'll be the end of this video on discontinuities, but remember, those are the kinds that there can be, and so hopefully this helped. Thanks for watching, and I'll see you on the next video.